What's this?
Python people, this is Prof G. Do you want to get your Raspberry Pi Pico to sling fat beats, deadly drops, mellifluous melodies? Well, now you can, using CircuitPython and Capacitive Touch to easily create your own DJ board. We'll use the CircuitPython audio mixer library to play multiple voices simultaneously, so that you, too, may bring on the funk. This is a no solder project, no MIDI software required. I'll show you how you can get grooving with some slimmed down sounds, but in a future lesson, I'll show you how you can add a micro SD card to add longer, higher quality beats to your mixology. Let's get to that funky coding and groove-filled big learning. Now, this project was inspired by the fantastic Todd Kurt, who's online as ToddBot. If you're not following him on the maker-filled magnificence that is Mastodon, definitely seek him out ASAP and follow his posts. Among other things, he curates a super useful list of CircuitPython tips and hacks that I recommend to all of my students. You can find this at the URL I'm showing here. It's also linked in the description of this video. Now, Todd's demo that kicked off my interest in this project was the One Knob DJ.
All right, here's how to be a DJ with one knob.
And I thought this was fantastic. Now, I'd never worked with Audio Mixer before, but when I saw this, I wanted to create a DJ board that would mix multiple sounds together for simultaneous play when you touch different capacitive touch pads. Now, Todd has a music background, and I don't, but the fact that I was able to get things up and running quickly is a testament to how groovy CircuitPython is. Now, in this build, I'll be using an ultra-low-cost Raspberry Pi Pico W. Everything works exactly the same in the Raspberry Pi Pico as well. For capacitive touch, I'll be using the Adafruit NPR 121 12-key capacitive touch Gator breakout. Make sure you're ordering the Gator version. There's another sensor with the same name that doesn't have these nice alligator clip-friendly pads, but the Gator version does. It's a super easy-to-use 12-pad capacitive touch sensor that we covered in an earlier CircuitPython school lecture. If you missed that, feel free to go back and check that out. It's in our playlist, which you see here, also linked in the description. And if you just want to use the capacitive touch pads on your Circuit Playground Bluefruit, you should be able to sub in code for that, which we covered in an earlier Circuit Playground capacitive touch lesson. Now, I've got the code that's used in this project in the GitHub repo at this URL, also linked in the description, and you can download the Beats folder with the sounds used in this project from the CircuitPython School Google Drive at this URL. You'll want to right-click on the folder named slim_beats and download that. It contains lower quality but lower sized files that we'll need for the Pico, since that board doesn't have much storage. Now, before we can move WAV files over to this project, the one thing we need to do is delete everything off of the Pico that we don't need for this build. Those 12 WAV files take up so much space that we need to strip everything out of the LIB folder and make sure we don't have anything on this board that we don't need. So to do this, I'm going to first head to my desktop. I'm going to create a new folder on the desktop. So on the Mac, I just right-click or two-finger click and select New Folder. Then I'm going to rename this Pico Backup. And then with my Pico board plugged in, I'm going to open up my CircuitPy volume, and I'm going to copy everything in CircuitPy into Pico Backup. This way I can restore this later on when I'm done with this build. Now, once that's done, I can head to the CircuitPy volume and delete everything except the LIB folder, code.py, and the boot_out.txt file. Everything else, sound folders, secrets, settings, all goes into the trash. Then, go into your CircuitPy's LIB folder and delete everything except for the single file Adafruit_mpr121.mpy. We don't need any of the other library files in this build, so drag all those other ones into the trash. So if you head to the root directory of CircuitPy and you look in LIB, you should only see one file in there, Adafruit_mpr121. Now, this extra step may or may not be necessary, but I find that, at least with this version of CircuitPython I'm working on, it doesn't seem to immediately reclaim all of the space for the files I've deleted. But if I click on the eject button and eject my CircuitPy volume, then I unplug my board and plug it back in, when CircuitPy appears next time on my desktop, I should have just enough space to copy my Slim Beats folder over onto CircuitPy. So I'll double check, and yes, this is the stripped down version of the Pico configuration that I need. So I'm going to drag over my Slim Beats folder and drag drop it into CircuitPy, make sure it doesn't go in the LIB folder, and then once it's copied over, your Pico should look like mine: boot out text, code.py, an LIB folder with only one file inside, Adafruit MPR121, and a Slim Beats folder with these 12 WAV files in it. By the way, if I take a look at how much storage I've got left on my CircuitPy volume, I can see I've only got 20K. Now, once you've got these things set up, we're ready to continue. Now, before we bust some code, let's take a look at how we wire things up on the Raspberry Pi Pico boards. As usual, wiring is the same for the Pico or Pico W. Now, this board doesn't have a STEMMA QT port, but you can buy a simple 4-pin cable with a STEMMA QT port on the other end. These sell for about $1, and they're very breadboard friendly. My students use these in our physical computing course. Or you can buy an Adafruit Cowbell, which is a board that the Pico can plug into. Just know that if you buy a Cowbell, you also need to buy stacking headers for this board, solder the headers on the board yourself, and you'll need to buy a cable with 2 STEMMA QT ports, since that cable doesn't come with a sensor. If you buy the wired port, the wiring is simple. As recommended in an earlier video, I suggest GP4 for blue SDA, GP5 for yellow SCL, power goes to 3.3 volt out, and any ground port for black. Now for the speaker, you can use any self-powered speaker with a standard audio plug. Here I'm using an inexpensive Hamburger speaker. You can connect any speaker with this kind of plug to the Pico using alligator pin wires. Just clip the audio input wire to the tip of the audio plug. In this build, I plug the other end of the wire into the Pico's GP15 pin, and the ground wire clips to the base or sleeve of the plug and attaches to any ground pin on the Pico. Now let me walk you through the code before we copy it and paste it and run it on our device. So to get things working, we need to import the libraries we'll need to extend the CircuitPython language for this build. We'll need board, Adafruit _MPR121, time, audio mixer, and audio core, and we'll import WAV file from audio core. Make sure you get the caps right. We have to use WAV sound files for this build, and we'll also import PWM audio out. Again, get the caps right, but we'll refer to this as audio out, capital A, capital O, and that comes from Audio PWM-IO. If you wonder why we don't use MP3s, the multi-voice technique we're going to use here doesn't work with MP3s, and the technique that we might use to play multiple tracks with MP3 simultaneously would choke the Pico because we'd need to create effectively 12 MP3 players inside our Pico. I haven't figured out a good way to do this with MP3 files. If you do, leave a message in the comments. Now we'll also configure the sensor with this code. As of CircuitPython version 8, board.stemma_I2C, open and close parens, will work not only for the Pico with the wiring shown, but also any board with a STEMMA QT port. And this line here creates a variable named touch_pad that holds the MPR121 object, and as this note points out, we refer to each of the individual pads on touchpad by following touchpad with the index value in brackets. Now this shows how we set up our sound files. They should all be in a folder with the same name as the string in this variable, path. Keep the backslash at the end of the folder name. This is used to separate out the folder name from the file name. And this list here named beats holds the name of all 12 files with a .wav extension. So all those files should be in that folder in your Pico. Mine is named slim_beats. If you're following along and copied over Slim Beats, you've already got these files with that folder on your Pico. Change the name of the files or folders if you're changing these on your own device. Then we get the number of files, which should be 12, and we store that in a variable named num_voices. Now we're going to play our sounds through what's called an audio mixer. It'll allow us to play multiple sound files or voices all at once. Now this is important to know. In this example, I've saved my sound files as 16-bit waves, so we've got the 16 in here. But while in an earlier lesson I mentioned that you could save wave files at 22 kilohertz or 22,000 hertz, I've actually decreased this to only 8,000 hertz. This decreased the sound file quality, but it made all of these files small enough so I could fit 12 files onto my Pico board. If you use Audio Mixer with new files, you want to do a few things. You want to make sure that you have your bit rate set at 16, and you want to make sure that the sample rate that you saved your files at is also used in this sample rate property here. So just as a reminder, in an earlier lesson I pointed out that you can download and use this free Audacity software for either Mac or Windows, and you can use this to configure audio files in the format that's needed by CircuitPython. Now here are the Audacity settings if you want to change things on your own. First you need to make sure that you convert files down from stereo to mono. Now usually we save files at 22,000 hertz or 22 kilohertz. You do this in this menu in the lower left hand corner, but again I used 8,000 or 8 kilohertz in this pull scroll-down menu. Also make sure that you save files as WAV files and use the 16-bit default setting. But if you change your sample rate, just make sure that you set your sample rate parameter here to match the hertz level that you use to save your files at. Otherwise, you're going to get an error when you try to read your files into the audio mixer. So again, want to save any files that you might have so that you can use them on your Pico, then you need to set the files to mono, not stereo, WAV files, no more than 22,000 hertz, but you can lower the quality if you need to squeeze them into smaller, lower quality versions, and make sure they're exported as 16-bit WAV files. Now, if you don't know anything about sample rates or bits per sample, well, you really don't need to know that as long as you get the settings right. Now, after we create the mixer object called mixer on this line, then we play it using the audio object that we created on the earlier slide. Now, it's not playing anything yet, but then we set this up down here. So we loop through all 12 of our current beats, reading in the file at the path, which is our folder, with the beat at an index value, which would be the name of that WAV file that we have in the folder, and it reads this in as a binary. That's what RB is, just ones and zeros, and this data is called WAV, so it's saved in a variable called WAV, and then on the next line here, we set up a mixer voice to play that WAV in a constant loop. Now, this is sort of like telling somebody in the choir to begin singing that sound over and over again. But in the next line, what we also do is we say, hey, only play that or only sing that song, play that track at the initial volume of 0. So nobody hears it initially because there's no volume. Now we repeat this 12 times. So we're actually playing all 12 files over and over again in a loop, but we're doing it at volume level 0 so nobody can hear it. Now we just wait a second after setting things up, which helps things catch up before we move on. And now in the while true loop, this is where the actual touchpad sound play happens. And this is done with just 6 lines of magical code. We first go through this for loop 12 times. That's the number of beats and touchpads that we have. And we'll do that over and over again. Now each time we go through the 12 individual values in this loop, we check that touchpad number's dot value property. And if it's equal to true, that means that touchpad is being touched. So what we'll do is set the volume level for that voice to 1.0, which is full volume. That begins playing the sound for the pad that's touched at full volume where previously it was silenced. Else, if that touchpad value is not being touched, then we'll make sure the volume for that voice is set to 0. So all 12 voices are playing simultaneously all the time, but we get to hear the sounds simply by touching a pad. That turns up the volume for that voice to 1.0 or 100%. That'll work if you touch multiple pads at the same time. But if you lift a finger off that pad, we'll set that voice level or the volume down to 0. That's it. Let's get our code and make your Pico board sing. So now with my Pico board plugged in, I'm going to open Moo, and then I'm going to open a browser, and I'm going to head to this URL. It's also linked in the description if you don't want to type it in, but it's github.com/Gallagher, that's GALLAUGHER, my last name has a U in it, /Pico-Beats. Now, if you scroll down, there's a README for this project and a wiring diagram, but all we need to do is click on the code.py link. That'll bring us to our code, and we can copy all of this code by clicking on this copy icon right here. It looks like one square on top of another. That means copy. And I'm going to paste it back into Moo. And I'll open my serial console and save this to my CircuitPy volume. Make sure it's called code.py, all lowercase, and I don't have any errors, so this is looking good. Now you can tap away at the MPR 121, or you can attach the pads to alligator clips and then clip those to anything that has capacitance. Fruit works, so does money. You can use actual euros to get some euro beats. And for this build, what I've done is I've printed out a page with an image of the MPR 121 on it. I've added some copper tape to these areas here to increase the area that will detect a touch. And I clipped alligator clips to the ends here. The other ends of these alligator clips are clipped to each of the separate pads that are on the MPR 121 sensor. You can get way fancier than this. In fact, I've encouraged my students to use capacitive touch paint and make a touch-sensitive mural for an upcoming arts festival. But if you want to print out a copy of this image, it's in the Google Drive for our course, the same place where you found the Beats folder. That's at bit.ly/circuitpython-school-files, all lowercase. Well, enough jibber-jabbering. I think it's time to jam. Now, before you're done, you should save a copy of this to your CircuitPython School folder as Pico DJ board. Feel free to play as much as you want, but when you're done, be sure to delete your Slim Beats folder. It takes up a lot of room on your board, and then copy over your Pico backup folder back onto your Pico so that you have all your libraries ready for the next example. So look at you, Code Monster, code like a blizzard with Python. You are a wizard. Let the funky fresh rhymes flow right out of your gizzard. I hope you enjoyed that rock on. Share your freshest beats. Post a short clip of you rocking out. CC me at Gallagher and use the hashtag BillWithProfG. And you might win one of the weekly sticker giveaways. And keep making the awesome.